Good evening, everyone. Today we are going to see the post on control chart types, selection, and implementation with an example. So basically, first of all, we should understand what is exactly a control chart is and what is the purpose of a control chart. Control chart is going to be a graphical mapping which is used to study how exactly a process is going to change with time. And whenever you are going to plot a control chart, we are going to collect the data and we are going to plot the data over time. So whenever we want to interpret different types of control charts, the key things that we are going to see is the lines which are involved in the control chart. So for an example, I got a control chart here. So if you are able to see in this control chart, there are different lines. First of all, we need to identify the center line. The center line is also known as the average line or the mean line. And over this and below this, you will be having two more lines which are plotted in red color. So these lines are known as the control limits of a process. In other words, we can say this is the voice of process, like where exactly the process is going to deliver the output. So the upper control line is known as the upper control limit and the lower limit is going to be the lower control limit. So let's say this is going to be X, like the average. So automatically what will happen is the upper control limit is going to be X bar or X plus 3 sigma. Sigma is nothing but a standard deviation in the data that we have collected. And similarly, the lower control limit is going to be X minus 3 sigma. So this is uh, the difference between the mean and the 3 times 2 the standard deviation of the data that we have collected. And also the control chart will help us to understand whether the process is in control or not. So here in this case, if you are able to see, all the data points are lying within the red color line, all the control limits. So from this we can say the process is in control. And sometimes what will happen is the data points will try to get across these control limits, and those type of data points will be calling it as the outliers. So those outliers should have been affected by some special cause variations. So even in these data points that we have collected, if we are able to see, all these are going to be varying from the center line. So that means we can say, so these data points are affected by some common cause variations. So common cause variations are always acceptable in the process. But whereas if you found any data points which are lying apart or across from these control limits, so those are nothing but the outliers, and those outliers must have been attributed by some special cause variations. So the special cause variations are nowhere acceptable. And depending upon the data, you'll be having different types of control charts like the IMR chart, X bar, R chart, X bar, S chart, P chart, NP chart, etc. So how to do these things and how to select these control charts. So let's take an example, or let's take the classification to understand better. So before going into that, we need to understand what are the different types of data available. So basically we'll be having two types of data. One is discrete and the second one is continuous. So discrete data is something like the data which can be counted. So if you are going to plot a graph for the batches that are being executed in different months of a specific financial year. So in such a case, we are going to count the number of batches. So that means the data that you are going to collect with respect to the batches are going to be the discrete data. So I am not discussing anything about the quality or the yield, but only the number of batches that has been executed in a specific financial year. So if you are going to count the number of batches in different months, so you can say it's a discrete data. Why? Because you are going to count the number of batches. While coming to continuous data, so this is something like the data which you are going to measure. So this is like, for the continuous data, you will be having certain units. Like let's say you have executed a batch and the output of a specific batch is 100 kgs, like the yield is 100 kgs. So from that we can say the data that you have collected is being measured. So that means you are going to measure the output in kgs. So it's a continuous data. So whatever you are going to count will not have any units. So you can say it is a discrete data. While coming to this continuous data, So you're going to measure it, and the data is going to have certain units. It's a simple way of understanding. And the next thing is coming to defect and defectives. This already I have discussed in my last video, where I have discussed about the Six Sigma metrics. And if you haven't gone through that video, please check the description of this particular video, and I'll be placing a link for the Six Sigma metrics for you. And coming to this difference between defect and defective. So defect is going to be something like a batch or something, we can say it means a specific batch is not going to meet a specific requirement. Like if a single requirement is not being met, so we can say it's a defect. While coming to defective, so it means failing of an entire product or service to meet a required criteria. In some cases, what will happen is even if the batches which are having certain defects can be accepted by customer, like it depends upon the customer. But while coming to defective, if a batch is found to be defective, the customer is not going to accept it. Why? Because it has failed in multiple ways. Whereas coming to defect, it should have failed in only a single way. So it's the difference between defect and defective. And coming to a real life example that I want to see is, like, let's say you're a BTech student, and if you are going to pass out from especially the JNTU university, so you'll be having certain type of cases or certain criteria to meet before getting your BTech certificate. Like if you have failed in two subjects, so you can get your certificate. Let's say in that case, if you have failed in only two or less than two subjects, so you say it's a defect. But if you have failed in more than two subjects, so you will be not getting your certificate. So you can say yourself as a defective. Like defect is going to be something which is going to be accepted by the customer, but it has some loopholes or it has some gaps. But while coming to defective, so this is not going to be accepted by the customer. Why? Because it's a complete failure of a product. So this is the difference between defect and defective. And the next one is we want to discuss something like about the subgroup size. Why I'm mentioning this? Because during the classification of control charts, so you should be knowing all these things like before going to the classification. So subgroup size is going to be the number of data points that we collect from a single unit that is being manufactured. Let's take example. So you're going to manufacture multiple batches, and you want to interpret the data of total 100 number of batches and the data you have collected. So if you are going to collect single data point from 100 number of batches, the subgroup size is 1. If you are going to collect two data points from a single batch and total number of batches are 100, so the subgroup size is 2. If you want to collect 3 or 4 data points, so the subgroup size can be the number of data points that you are going to collect from a batches that are being interpreted, we can say. So this is about the subgroup size. And now let's see about the classification part. So for this I will be using the smart chart. So here we got the data. So this I don't want, I'll be removing. And in this data section we can classify it into two types. One is discrete and the second one is continuous. And coming to this discrete, I'll be having two more classifications, like where I am going to measure the defects or defectives. So coming to defects, so here again I am going to classify this into two categories. One is constant subgroup size and the next one is variable subgroup size. Okay, and coming to this constant subgroup size, if it's a constant subgroup size, you can say this as, like, the chart you can use is the C chart. And if it's a variable subgroup size, so in this case, if you want to interpret the data or if you want to plot a control chart, you can use the U chart. So I'll be showing you in the Minitab where these type of charts are available. And now coming to the defectives part. Again, we are going to classify this into two categories. One is constant subgroup size, and the next one is variable subgroup size. And coming to this constant subgroup size, so if the subgroup size is constant, then you can use the NP chart. And if it's a variable subgroup size, so you can use the P chart. Okay, and this is about the discrete data. And now coming to this continuous data. So here you are going to classify depending upon the individuals or subgroups. Individual means if you are going to collect single data point, it's an individual. And if you are going to collect multiple data points, it is nothing but a subgroups. Or else if the subgroup size is 1, you can say it's a individuals. So coming to this individuals, if the data is individual data, then you can say, or you can plot a IMR chart. And coming to this subgroup size, like subgroups, if the subgroup size is less than 8 and subgroup size greater than 8, so what you can do is, if the subgroup size is less than 8, then you can use X bar R chart. And if the subgroup size is greater than 8, in this case you can use an X bar S chart. So this is how you can classify or you can select the different types of control charts. Okay, so I'll be attaching this particular Excel sheet for download in the description, and I'll be providing you the download link so you can download. And now I'll try to take an example and I'll explain you how to plot a control chart in Minitab. So the data that I have collected is related something to a pharmaceutical industry, and here I have selected the data of a acid content. So usually what will happen is, in a pharmaceutical manufacturing, you will be having different types of acids and bases. So whenever you want to take a specific API, like sometimes what will happen is, usually the product, the main or the key product is going to be in terms of a base, and you are going to isolate it by adding different types of acids like HCl or any kind of a inorganic or sometimes some kind of organic acids. And as a part of quality testing, you will be measuring the acid content. And I have collected the specific data of acid content here, and for the same I want to plot a control chart. So from total 46 batches, sorry, 47 batches I have collected data, and the same data has been plotted here. So I'm going to take the same data, I'm going to paste it in the Minitab, total 47 data points. Since I have collected one data point from a single batch, I'll be selecting an individual moving range chart. The reason is, the data that I have collected is a continuous data. Why? Because it got a units like percentage weight by weight. And also at the same time, so I have collected only one data point from a single batch. That means the subgroup size is 1, or in other words we can say this is an individual data. So I'll be selecting IMR chart. So first of all, get into stat and then get into these control charts. So in these control charts you can find this variable charts for individuals. So in that you can say IMR. And also, as previously mentioned, you will be finding different types of charts here: X bar R, X bar S, X bar RS, and these attribute charts P, U, C, U, and P. So these are the charts that we have discussed earlier in this video. And now coming to the data, as it corresponds to individuals data, I'll be selecting this individuals and I'll be selecting this IMR. So this is how the dialog box will look like, or this is how the data window is going to look like. In this, click on this variable and just click on or this ACID content and select it. So after doing that, so just click on OK. And if you want to explore more options, you can click on this IMR options, and here in this you will be having different types of options. You can use this, and in the coming video I'll try to make a video how to use this type of options. So for now, simply I'll be plotting a IMR plot. So Minitab is going to plot the IMR plot or the IMR control chart. So here, if you are able to see, Minitab has plotted two different plots. One is the individual value and the second one is for the moving range. Moving range means so how the data is going to change from point to point. Like the difference between data point 1 and 2 is going to be the first data point in the moving range. So as previously discussed about the interpretation, so let's take the individuals chart. So the center line is going to be the average line. So the average of the data that I have collected is nothing but the X bar, and the value is 9.183. And I got two more lines above and below to this average line. Those are the control limits. So that above line is going to be the upper control limit, which is almost 11.004, and the lower control limit is 7.362. So that means this is how the process is going to, this is where the process is going to give us the output. Okay, and as previously discussed, if you are able to see, all these data points are lying within the control limits. That means so there are no outliers in this individual's chart. If you are able to see in this moving range chart, there is one outlier which is crossing these control limits, and this outliers corresponds to certain special cause variations in the process, and the remaining data points are going to vary between the control limits. That means so these are attributed by some common cause variations which are allowed in the process. So the outliers indicate some special causes which are not allowed in the process. So there should be certain abnormality in the process, especially in this data point. So it's a data point number 15 where we need to observe and investigate. Okay, so this is how we are going to interpret the control chart. And now just click on OK. So this is how you are going to identify the data, like the type of data, and depending on the type of data you are going to select an appropriate control chart. So this is the brief selection. Okay, and the next one is about the implementation, how to implement the control charts. So whenever you are going to plot these control chart continuously for a data periodically, what will happen is you can understand whether the process is in control or not. Like in this Minitab, especially this control chart, you can see. So for the total 47 data points that I have collected, I can say the process is within control, and if any outliers are there, from that we can say the process has deviated at that specific data point. And now coming to this implementation part. So there will be steps involved in this implementation part. First thing is we need to identify what to measure and what to control, and the next one is define sample size and frequency, and the third one is determine rational subgroups, and the fourth one is select appropriate control chart, and the fifth one is take initial set of data from the process and determine the control limits, and the next one is verify the stability, and if stable, lock the control limits, and then develop And out of control action plan, it's nothing but an investigation what you want to do. And then we need to train the people who are involved. Nothing but whenever you are going to conclude certain investigation, you need to train the people who are involved in this manufacturing, and also you need to train the people who are involved in the interpretation part. And then we need to continue monitoring the process using control charts. So these are the different steps involved in the implementation of control charts. Okay, so this is all about the different types of control charts, selection, and the implementation. Hope you like the video, and if you have any questions in this video, then please get in contact with us by writing a mail at pharmacalci823@gmail.com. And also, if you like our video, please subscribe to our channel and also share it with your dear ones. Thanks for watching the video.